It is now time to take the concepts we've learned and apply them in OSPF configuration and troubleshooting. We're going to look at, as we walk through here, the general syntax. That's how we'll start off. We'll look at the diagram. We'll look at the general syntax to set up OSPF and get it running on all our routers. As we do that, we'll be verifying what we're doing. You can see verification is my final thing, but we'll be verifying what we're doing as we go. The second concept I want to talk about is the router ID, or the name of the router, what importance that has and how to set that. And then finally, we'll look at the verification and troubleshooting commands with OSPF. So let's get going. Configuring OSPF is not much more difficult than configuring most of the routing protocols, but there are a couple tweaks that I need to show you. First off, here's our network diagram that we've been using thus far and will continue to use. We've got router 1, router 2, and router 3. Now, as of right now, they're all running RIP, and we're going to convert that over to run OSPF. Now, if I were to diagram out my areas, and this is going to be a really rough sketch, I would go in here and I would say this, router 1, encompass all the way down here, router 2, and what I'm going to do is this is all area 0. Now, the first thing I want to mention is that the CCNA exam, if you are an exam prepper, the CCNA exam only tests on something known as single area OSPF, which, in my opinion, okay, a lot of people run OSPF in a single area, a lot of small to medium-sized networks, which is why they test on it in the CCNA. The CCNA is meant to operate in those environments. But to really understand the power that you have with OSPF, you got to see multi-area configurations. So forgive me, I'm going to add it in here. We're going to make this area 1. Now, a multi-area configuration is so much, well, I will say it is so little more. This is horrible English here. There's not much more to it, is what I'm trying to say. You're going to see the single area config. I'm just going to add 1 or 2 more commands, and you'll see it convert to a multi-area configuration. And you can see this to simulate this environment. Because we only have 3 routers here, I'm going to pretend that router 3 has connections to all these 172.16 networks in area 1. And we're going to break it off, and we're going to summarize. It's going to be awesome, I'm telling you. So that's the scoop. So first thing I'm going to do is I'm going to hop over to router 1. And let me get my terminal ready here. Bring it into view. There we go. I'm sitting on the access server. I'm going to go to router 1. I'm going to type in show IP protocol just to verify. Yep, RIP is still running. Let's kill it. I'm going to go in and type in no router RIP, which turns off RIP on router 1. Hangs there for a moment because it's shutting down the whole process. And now we're going to add OSPF. We've got no routing protocols running. So I'm going to type in router OSPF followed by a process ID. Now this process ID just identifies the process on your router. For example, if you go on Windows and open Task Manager, let me see if I can open it here. Right here I've got all of these different processes running, and Windows will actually identify them all by a process ID. And if you get into in-depth, how Task Manager operates, you're able to kill processes with Windows. Same thing with Linux. Well, in a router, you need to identify what process ID this OSPF will be identified as. It does not have to be the same on all the routers. I could use 1 on router 1 and 50 on router 2 and 6,000 on router 3. But with that in mind, most people will make it the same on all your routers, because if you make them different, you have to remember it on every router you go to. So I like using router OSPF 1. Now once I'm under here, I need to type in my network commands. Now think back to RIP. The network command does 2 things. It identifies what networks to advertise. For example, when I identify and say 192.168.1.1, this network will be advertised this direction. It will say, I know about 192.168.1.0/24, and I will advertise that network. And the second thing the network command does is say, send hellos in this direction. Now with RIP, there were specific ways we had to type in the network statement, and samely so with OSPF. OSPF has a very specific way to type it in, which is far more flexible than RIP. But also keep in mind, I've got my internet connection running over here. Do I want to advertise that to the rest of the OSPF domain? No. And in the same way, do I want to send hello packets out here? No, because that's not secure. I don't want my ISP to form an OSPF neighbor relationship if they wanted to. So this interface will be exempt from both of those criterias. Now, I know some of you might be thinking, well, you want the routers in your network to access the internet, right? You got the internet right over here, so shouldn't you advertise this link to them? Well, yes, we do want them to access the internet, but at the same time, advertising this link will not allow that. That will just allow them to access this link. We need to advertise in a default route, meaning all zeros. Remember that 0000 route? We need to advertise that into the network so everybody has a default route out of the corporate network. So we'll have to remember to do that. First off, let's turn it on router 1. I'm going to jump back to my terminal, and I'm going to type in network, followed by what network I want to advertise. In this case, flip back, I'm doing 192.168.1. So 192.168.1.0 is what I'm going to advertise. Now, this is the same so far as RIP, right? In RIP, we would type in the classful network we want to advertise. 192.168.1 is a Class C network, so I'd type that in. But OSPF requires, notice, incomplete command. It requires that I add on something known as an OSPF wildcard mask. Oh, the wildcard mask. I love this concept. It is unnecessarily complex for no good reason. Everybody that I've taught this to is like, why did they do it that way? I don't know. Just because. That's what Cisco does. And this isn't just a Cisco thing. Just about every router will require wildcard bits. So what is a wildcard bit? What it is kind of like a match statement. Here's the idea. I'm going to come back over here, and if I were to go to router 1 and type in network, where's my pen, 192.168.1.0, I have to follow that up with wildcard mask, and a wildcard mask, the simplest way I can define it, is exactly the opposite of a subnet mask. So I would go in here and do 0.0.0.255. What? That's right. Remember, our subnet mask is 255.255.255.0. That's Class C. A wildcard mask is exactly the opposite. If you want the simple formula, just take 255, 255, 255, 255, and subtract your subnet mask from this, and you'll get 0.0.0.255. That's how you figure out wildcard masks. Now, I know you're looking at that going, I don't need a formula for that. But when we get to access lists, you'll thank me for that. Okay, here's what it means. I know, just throwing this out there doesn't mean anything. Anytime you see a 0 in your wildcard mask, line it up and match it to the network that you've typed in. So 0 matches here. 0 matches here. 0 matches here. In deeply technical terms, that means look at these, meaning look for interfaces that begin with 192.168.1.0. The 255 means, in technical terms, I don't care. What that does is now instruct the router, when I type in that wildcard mask, look for interfaces on yourself. You've got Ethernet 00. Look for interfaces that start with 192 as the first one. Look at these, 168 as the second one, 1 as the third octet, and then I don't care what comes after that. In this case, we have a .1 on the interface, but it's saying I've got a .0, but this could be anything from 0 to 255. You could have any IP address on here that starts with 192.168.1, and OSPF will say, I don't care about this last digit right here. I'm going to run OSPF on that interface. So this gives me a more flexible way of identifying interfaces. For example, let's jump down to router 2 here. If I was on router 2, check it out. I've got 192.168.1 in one network, 192.168.2 in another network over here, and 192.168.10 and 20 as sub-interfaces that are routing between my VLANs here. Now, if I were to do this with RIP or with a wildcard mask of this, I would have to type in 4 network statements. Network 192.168.1.0.0.0.0.255 is the wildcard mask. Network 192.168.2.0.0.0.255 is the wildcard mask. So you can see it's kind of inefficient. So I could go in there and say, well, I'm going to type in network 192.168.0.0.0.0. Any guesses? 255.255. Again, what this means is I will run OSPF and advertise any network that starts with 192. Look at this. 168. Look here. 255 says I don't care and I don't care. So immediately, OSPF goes on the router and begins looking at all of the router's interfaces. It goes, oh, well, this one starts with 192.168, and I don't care what comes after that. This one over here starts with 192.168, and I don't care what comes. Wow, my pen got bigger. I think I clicked something or something. This starts with 192.168, and over here, I don't care. So it's looking and identifying every interface that starts with that 192.168. That's the power of the wildcard mask, is it gives us the flexibility of what to type in. Let me give you one more example. Let's say I'm on router 3, and I only, let me see if you can pick up my point here, I only want to run OSPF on specifically this interface. I don't want any other interface in here to run OSPF. No matter if I add interfaces in the future, I want to make sure that only that interface will run OSPF. Are you catching my hint? I'm going to type in, to do that, network 192, with my big kindergarten marker here, 168.2.2 with a wildcard mask of 0.0.0.0. That says run OSPF on specifically, look at this, look at this, look at this, look at that. Every part of that IP address is specifically identified, so it will only run on there. Now, I use this wildcard mask all the time, not only because it gives me complete control of how OSPF operates, meaning I get to identify exactly the interfaces it's going to run on, but also it eliminates a lot of the complexity in my own mind of what I need to type in. I mean, if you think about it, if you want to run OSPF on a router, all you got to do is go to that router and type in, let me do a do command, do, and if you haven't seen it, do does show commands from any mode, do show IP interface brief. And I say, okay, those are my 2 interfaces, so I'm just going to identify that, network 192.168.1.1.0.0.0 is my wildcard mask. That's what I would type in to start on just that. If I wanted to run it on my internet link, I would type in 68.110.171.98.0.0.0.0, and that would run it on exactly that interface. So that's how the OSPF network command works. Let me clean off all this gibberish. There we go. That looks a little better. Now let's get into the configuration. So I'm going to go to router 1 and type in network. Well, let me just do that. Show IP interface brief. Do. And I'll do network 192.168.1.1. And I'll use my shortcut 0.0.0.0.0. Now let's see what it's looking for next. Area. Yep. And then what area do you want? And I can type it in. And we've already determined area 0 is the backbone. It's always the first area that you configure. Good. So by typing that in, I am now running OSPF on that interface, and I'm advertising the network that belongs to that interface, 192.168.1.0/24, out into the rest of the world. Now, I want to make sure I emphasize, because this boggled my mind when I got into Cisco, what you type in here is not what you advertise. You are not advertising 192.168.1.1. You are advertising the network that belongs to that interface. When I type in show IP interface, and look, the 192.168.1.0/24 network belongs to that interface. So that's what you're advertising. So I can type in show IP protocol now. And see, I am running OSPF. I'm currently routing for that network, which belongs to Area 0. My router ID is this. That's the name of the router, and we'll talk more about that in just a moment. And so my first router's done. Now, I'm not going to have any routes because I haven't formed any neighbors. We'll see a command, show IP OSPF neighbor, which will show your neighbors, none. I have no friends. So sad. So router 2 over here says I need to join this OSPF network. So let's hop down there. Router 2, and I'll do config T, no router RIP. Goodbye RIP. It is now disabled on router 2. Router OSPF 1, let me do that. Do show IP interface brief, and there's all my interfaces on there. Let's use the wildcard mask to our advantage here. I'm going to do network 192.168.0.0, 0.0.255.255. And remember, that says I care about any interface starting with 192.168. That's all of my interfaces on this router. I will add those to area 0. The other area, the other part of the IP addresses, I don't care about. So all the interfaces on here will begin running OSPF as soon as I type this in. I hit enter. We're now running OSPF on all those. Let me do a show IP OSPF to prove it. I can see that, oh, that's not what I want. Show IP protocol. Oh, check that out. I was trying to get there before our neighbor would form. But, good grief, I'm just not lucky here. Show IP protocol. We see I'm running OSPF. I'm routing for all the networks that start with 192.168. My router ID, or the name of my router, is 192.168.20.1. So when I do a show IP OSPF neighbor, now look at that. I have formed a neighbor on OSPF. They are 192.168.1.1. Their IP address is 192.168.1.1. This is the router ID, the name of them. This is the IP address I use to communicate. And this is the interface I go out to speak to them. Look back at our diagram, and we can see, sure enough, that's router 1. This is us, router 2. And we're speaking out fast Ethernet 0/0. Now let's hop back up to router 1 and do a show IP OSPF neighbor here as well. I can see that I have a neighbor, 192.168.20.1. That's their router ID, the name of the router. But I'm communicating with them on the IP address 192.168.1.2. Again, I have a whole slide dedicated to the router ID in just a moment. But for now, I can see I've formed neighbor relationships. So when I do a show IP route, I expect to see, drum roll please, OSPF routes. Check it out, and there they are. OSPF 192.168.20. OSPF 192.168.10.0. Oh, look at that. I have a static route. I had that in there from when we were doing our VLAN labs. Let me do a show run. Check this out. I'll show you a cool shortcut. Include lines that have IP route in them, because my static routes are IP route. So I can go in there. I want to remove my static route. I don't need it anymore. OSPF's doing it for me. No, paste it in there, IP route. That's exactly what I had in my running config, so I'm removing that. Now when I jump back, I expect to see my static route replaced by an OSPF route. Good. We don't need statics anymore. OSPF is doing the work for us. So we are now learning all of these routes via OSPF, and I have my default route down here going to the internet. Now let's just see something. Let's jump down to router 2 and see if it knows about the default route. Do a show IP route. Oh, bummer. Look at that. No default route, which means no router 2 getting to the internet. Let me show you how OSPF takes care of that. On router 1, the one with the default route, I can go under the OSPF process and type a single command. Default-information originate. Think about that command. Any default information that you have, aka default route, go ahead and originate that, meaning send that into OSPF. So send that to other routers. Now when I go back down to router 2, show IP route, sweet, look at that. OSPF route has now shown up on router 2. Router 2 now has this is E2, external type 2 route to the internet through router 1. Now, as this is where I lead you into the CCNP. In the CCNP, you'll learn the difference between external type 1 and external type 2 routes and what those are all about. But for now, router 2 has a default route and should be able to get to the internet once we set up NAT, and that's coming. So router 2 is now good to go. Now, let's hop on over to router 3, because router 3 is still running RIP. I'll go to 3. No router rip. Goodbye. I'll do router OSPF1, and underneath router 3, let me do a show IP interface brief. I can see that I have my Ethernet interface right here that's connected to the LAN, my serial, which links back to the WAN, and then all these quote-unquote simulated networks. They're considered loopback networks with all these IP addresses, and that matches the network diagram over here. I'm going to show you first off area 0, getting that set up, and then I'll add in our multi-area. So I'm going to type in network. Let's do the same thing here, 192.168.0.0.0.0.255.255 area 0. That will add any interface with 192.168 in front of it to area 0. And you can see I've formed a neighbor relationship. I can do a show IP OSPF neighbor. And there I see my neighbor. I can type in show IP route, and my router is now receiving OSPF routes, even the default route from over at router 1. So it is able to get out and access the internet. So with that in place, and I can tell you, that's virtually what you need to know for the CCNA exam. That's how you set up OSPF in a single area. Let me expound now. Let me have the change released, and I will add in area 1. I'm going to go in, and I'm going to type in network 172.30, because I've got 172. Oh, no. I don't match what I really have. These are 172.30 networks. I accidentally put 172.16 over here on the diagram. So imagine, pretend those all say 192.168.30. And then I have 0, 1, 2, 3, 4, 5, 6, 7. You want to see something fancy? I'm going to show this to you because we're going to need it when we get to access lists. But how would I create a summary route for those? Well, think back to the previous video when we talked about route summarization. I would go in there, and let me actually type this. This will be a little cleaner than trying to scribble it in there. Give myself a bigger font. 172.16, and this is 172.30. Sorry, I mistyped those. 0.0 in binary. 172.30 is the same between all of them. The third octet is what I'm concerned with, so let me go in there. In binary is all zeros. 8 zeros, and the last one is all zeros. Okay, but let's just focus on the third. I'll just do first 3 octaves. 1 is 172.30.1. 2, 172.30.10. That's 2 in binary. 3, 172.30.11. You're getting the idea. So if I were to go all the way down to 7, 7 would be 172.30. 1, 2, 3, 4. This will be 16, 8, 4, 2, 1. That is 7 as a binary number. So by grouping all those together, I am able to say that 172.30.0 through 7 have the first, let's see, we've got 8 bits in common, 8 bits in common. So that's 16, 17, 18, 19, 20, 21. So this is my dividing line. You can see this is where 0 through 7 are all different. So I can say that I have 5 bits here. So a summary route for 172.30.0.0 through 172.30 is 7.0 is 172.30.0.0 slash 16 plus 5 is 21. Or if I were writing that summary route in decimal, 172.30.0.0 with the subnet mask 255.255. Let's see, slash 21 would be 248.0. That would be the decimal version of the subnet mask. So that's a summary route that groups all of those up. Now let me show you. Now this is what I'm going to show you is just at this point showing off. Not showing myself off, but if you were to do this for somebody, you'd be showing off. But I'm going to demonstrate a skill that is going to give you a great success when you get to access lists. What wildcard mask could I type in on router 3 that would run OSPF on just those interface? We have a subnet mask that says this subnet mask matches 172.30.0 through 7. Are summed up in this. And remember the formula I gave you? How do you figure out a wildcard mask? You take all 255s and subtract the subnet mask. I'm going to subtract that summary subnet mask 248.0 equals 0.0.7. 255 minus 248 is 7.255. 255 minus 0. That is a wildcard mask that will run, that I can use to identify to run OSPF on only interfaces starting with 172.30.0 through 7, because this is a summary route that encompasses networks 172.30.0 through 7. Now, like I said, this is just showing off because you can accomplish the same thing by going in here and typing 172.30.0.0 with a wildcard mask that looks like that. And that would work because all these interfaces start with 172.30, and that's what we're saying is important here. But we could also do 172.30.0.0.7.255, and that would say run OSPF on any interface that starts with 172.30, and because of this, it's saying and has 0 through 7 in the third octet. That's how to impress your friends. But when we get to access lists, that will become an invaluable skill because that'll help us be very specific with what we want to deny or allow. More on that later. For now, I'll use our bragging wildcard mask there, and I'll say this is in area 1 because looking at our diagram, that's where we are. So when I hit enter, I have, by typing that one command, created an ABR, an area border router that is routing between two separate areas. Now, that is all there is to it. There's no I am an ABR command. So I can go in there and type show IP protocols, and I can see that I'm routing for 192.168.0.0 in area 0, and I'm routing for this network in area 1. Now, when I go back to router 2, check it out. I'm going to go to router 2 and do a show IP route. Oh, that's awesome. Awesome. Look at that. We have OSPF routes in our table, the default route that router 2 is getting from router 1. And remember where router 2 is. Router 2 is right here. It's only going to learn about the default route because it already knows about all this network over here. And it's going to learn about this route, the 3.1 in its own area. And all these are in area 1. And look at this. There is the 3 dot, which it sees as just a normal OSPF route. And all these are area 1 routes, a.k.a. inter-area. See our little IA there? That is identified as an inter-area route. Now, as I mentioned, if you're just breaking into multiple areas and not doing summarization, you're doing no good. And this is something I mentioned in the previous video, because that's the whole point of breaking into multiple areas is now you can summarize. Now, I know, I'm going beyond the CCNA here. Again, let me emphasize, CCNA is just a single area, but I've got to show you this one final command. I'm going to go, whoa, holy cow. There's Vista for you. I'm going to go to the router 3, and I'm going to type in router OSPF 1, and I'm going to do area 1 range, and then what I want my summary route to be. Now, we already figured it out right here in our binary. Our summary route for area 1 to encompass all 7 of those networks will be 172.30.0.0/21, or with this subnet mask behind it, that's a good summary route to encompass just those 7 networks. So I'm going to jump back over here and do area 1 range 172.30.0.0, followed by a normal subnet mask, no wildcard mask, 255.255.248.0. Done. I have now encompassed, and I've told router 3, which is an ABR, the range for area 1 is 172.30.0.0 with this subnet mask, which emphasizes 0 through 7. Now, let's check this out. I'm going to go back to router 2 and do a show IP route. Look at that. Isn't that, oh, I'm telling you, you'll get this excited when you get into OSPF. We've got this, which it shows /21. It even did the mask for us. It said, you typed in that subnet mask, which is also a /21 there. And you can see right there is subnet, and we have one inter-area route that is available to us, a summary route. Notice all 7 of those previous routes that we previously were looking at in that routing table have disappeared and been replaced by one summary route. Now, watch this, hang on. Oh, am I going too far? I'm going too far, but I've got to do this one more thing. I'm going to create one more network. You see my loopback interfaces right here, 172.30.0 through 7. I'm going to create one more. I'm going to do interface loopback 8. This is how you can simulate networks, by the way. I'm going to do IP address 172.30.8.1. I'm going to add another network that's not part of the summary mask. Because if I go down here, 8 in binary, I'm running out of room, man. I'm going to say 8 is 0000100. That's 8 in binary, which does not have the first 5 bits in common, which goes outside of our summary mask. And when I add that in there, oh, wait a sec. I used the custom wildcard mask to add that to OSPF, didn't I? We'll have to do that something. Ignore what I'm typing right here. Just ignore it. You are not seeing what I am typing. Did you see that? I didn't see that. And I'm going to type in network 172.30.8.0. With that is my wildcard mask. So I've added that network to OSPF because with our custom wildcard mask before, we just added 0 through 7. That manually added 8 in there. Now if I go back to router 2, show IP route, look at that. It's separate. The summary doesn't encompass it because the summary only includes 1 through 7. So what we've proved by doing this is that our custom summary mask is working perfectly, encompassing just the networks that we wanted to. So yes, we did go beyond the CCNA, but that is multi-area OSPF. That is a big part of the CCNP. Whew, I got to breathe there. OSPF is exciting. I'm telling you, it's a very cool protocol. All right, last few concepts we'll talk about in this video is, number 1, understanding the router ID, and then number 2, we'll just look at how to troubleshoot OSPF, which is really focused around one thing. So the OSPF router ID is the name of the router. We've seen it a couple times when we were going in. If I'm on, let's shoot over to router 3 and do a show IP OSPF neighbor. Router 3 sees router 2 as the router ID or neighbor ID 192.168.20.1. But it communicates to router 2, its neighbor, on the address 192.168.2.1. And if we look back at our network diagram, where'd that go? Diagram. That's right. You can see router 3 communicates to router 2 on 192.168.2.1. So why is router 2 identified as that, 192.168.20.1, when we're looking at its router ID? You can see 20.1. That's its router ID. That's because of this rule. The OSPF router ID identifies the routers to neighbors. It's the name of the router. It is by default the highest physical interface at startup. So if you've got this router sitting right here and you start the OSPF process and router OSPF 1 and you go in there, the router ID will be this guy. The highest physical interface, 210.6258.1, beats this and beats that because it is the higher interface. Now, loopback interfaces also beat physical. So if I go in there and add a loopback interface of 1.1.1.1, an extremely low IP address, since it's a loopback, it automatically wins. Now if I add another loopback of, we'll say, 5.1.2.1, this one now wins because it's the highest loopback. And there is a new command, router-ID. The new router ID command beats all. So let me show you what this looks like. I'm going to go into router 2. Or we're on router 3. Why not stay there? I'm going to go in and do router OSPF 1, and I can hard code in there, and a lot of people will do this, router-ID 3.3.3.3. Enter. Now that is the new name of the router. It says, in order for this to take effect, you have to reboot the OSPF process. So I'll add in clear IP OSPF process. It says, are you sure? Yes. Not something you want to do during production time. But this will take down the neighbor. You can see the neighbor is gone from full to down, and then reload it. It went back in, and it's now full again. Neighbor reformed. So I go over to router 2 and do a show IP OSPF neighbor, and now I can see that? 3.3.3.3. That's the name of router 3 that it sees, and it communicates with router 3 using the IP address 192.168.2.2. Now, at this level, we're only mentioning the router ID as just say that that's the name of the router. But as you get into the CCNP world, you'll see that the router ID has a lot more ramifications. There are commands that you type in that require you to know the name of the remote router, or the router ID. So at this point, that's just what the router ID is. Finally, as we move into troubleshooting OSPF, this slide should look somewhat familiar to you. This is the same slide we looked at in the previous video when we talked about how routers form neighbor relationships. 90% of your troubleshooting in OSPF is focused around routes not showing up because neighbors aren't forming. So the best thing that you can do as you troubleshoot is to do that show IP OSPF neighbors command. Do you see a neighbor there? Chances are, if you're not seeing routes, you're not seeing a neighbor. So you're going to go through and mainly look at these criteria. Do the hello and dead timers match between me and my neighbor? Are we using the same subnet mask on the interfaces that we use to communicate? For instance, is this one a /24 and maybe this one a /25? Neighbors won't form. Are we in the same area? Has this one been defined in area 1 and this one defined in area 0? That would be a conflict. Neighbors. Wait a second. That's not right. Neighbors, this shouldn't have a star. Forgive me. If you've jotted that down on a piece of paper, it is not. That should not have a star. I can't believe I did that. Neighbors is a list of what neighbors each one of these knows about. It'll say, I know about these as my neighbors, and I know about these as my neighbors. That's how the routers know when they send hellos back and forth if they're already neighbors or not, if they see each other listed as a neighbor. That does not have to match. Forgive me. Priority, DR, and BDR, those are CCNP concepts, but the password. If you are password protecting your OSPF network, so routers can't just come in and join the routing fun without providing a password, it will say, does the password match between these two routers? If not, the neighbor relationships will not form. So again, just going through and checking these 4 criteria, hello and dead timers, subnet mask, area ID, and password, that will tell you whether or not these neighbor relationships are forming. If you want to troubleshoot this process even further, the best way to do it, let me get my thing moved in here, is to do a debug IP OSPF and its adjacency, ADJ. That will show you the neighbor relationships forming. When I clear my process, clear IP OSPF process, you'll actually see on the screen it shows neighbors going down. It shows neighbors coming back up. It's a lot of info, but this is a complete neighbor forming process between, that was the second neighbor coming up, and everything it goes through as it forms a neighbor relationship. If there is a problem, if there's an area mismatch or a subnet mask, it will be in this output that just scrolled up on my screen. It will say, oh, neighbor's not going to be forming because the area ID does not match, area match conflict, or because my authentication password fails. So doing this one debug will show the full neighbor process forming. Just walking through that simple configuration of OSPF, I feel like there's this can of OSPF concepts that I just want to open and just say, let's talk about everything. But then this video would be 5 hours long, and we would have just a lot of stuff that does not relate directly to the CCNA. As you can hopefully get an idea of just by seeing this, there is so much more that you can do with OSPF, but that should give you enough at the CCNA level to set it up, to do basic route summarization, that's even beyond the CCNA, and to understand, here's the key, you should be able to understand any OSPF config that you come across in the real world just by doing a show run and seeing what commands that have been typed in. To wrap up, I want to hit the high points. We looked at the general syntax to configure OSPF. The major difference is that wildcard mask with the network command. We then saw modifying the router ID, which is the highest physical interface by default, the highest loopback interface if you have one of those on your router, and can also be modified by typing router-ID from router config mode and whatever you want your router ID to be. Finally, we looked at the verification and troubleshooting. Verification we did throughout the configuration, looking at the routing table, looking at the neighbors, and troubleshooting we did by looking at the debug command, debug OSPF adjacency.